Neural Network 101, Unveiling the Weights and Inputs Dance. Imagine you're running a restaurant and trying to predict which dishes your customers will order. A basic neural network is like a team of chefs, each with a special recipe for predicting orders. But how do they know what to cook? That's where inputs and weights come in, the secret ingredients in their decision-making. Inputs. Think of these as the raw ingredients, the data the network receives. For our restaurant example, inputs could be things like day of the week, weekend, weekday, time of day, lunch, dinner, weather, sunny, rainy, group size, solo diner, family, weights. These are the secret spices that give each chef's recipe its unique flavor. They represent the importance of each input for predicting an order. A higher weight means that input has a stronger influence on the prediction. For example, weekend orders might have a higher weight for desserts compared to weekdays. Lunchtime orders might have a higher weight for salads compared to dinners. Putting it all together, 1. Each chef, neuron, takes a set of inputs. Think of them chopping up the data. 2. Each input is multiplied by its corresponding weight. Imagine weighing each ingredient based on its importance. 3. All the weighted inputs are added together. This is like mixing the ingredients in a bowl. 4. An activation function is applied to the sum. This is like the chef's special touch, transforming the mixture into a prediction. In our case, it might be a probability for each dish. 5. The prediction is compared to the actual order, if known. This is like tasting the dish and seeing how close it is to what the customer wanted. 6. If the prediction is wrong, the weights are adjusted. This is like tweaking the recipe based on feedback. Higher weights for ingredients that were underpredicted, and lower weights for those that were overpredicted. Remember, the more data the network is trained on, the better it gets at adjusting its weights and making accurate predictions. Different types of neural networks have different architectures, arrangements of chefs and recipes, but the basic idea of inputs, weights, and learning through adjustments remains the same. So, there you have it. Inputs and weights are the fundamental building blocks of neural networks, driving their learning and prediction abilities. With this basic understanding, you can start exploring the fascinating world of these artificial brains and see how they can be used to solve all sorts of problems. Bonus. Think of the bias term in a neuron as a pinch of salt, adding a constant value to the mix. Different activation functions can introduce nonlinearities, making the recipes more complex and powerful. I hope this lecture was helpful. Feel free to ask any questions you might have about the world of neural networks.